I will start. I will continue talking about cross-lingual word embedding. And as we all know that unsupervised learning have several problems, and so maybe our weakly supervised learning is a kind of better solution. So when people talk about cross-lingual word embedding, we usually think about a shared space where we can find the source word, the target word, and the geometric position of similar words across different languages is very close. So here we have an example of a shared embedding space for English-French. There are several solutions for building cross-lingual word embedding. The easiest one is called cross-lingual word embedding mapping. For doing this, we need to have a source pre-trained model and a target pre-trained model. We need to train, what we want to do is to train a mapping matrix which minimize MVS and VT. The traditional supervised method use a dictionary, a word-to-word level dictionary. But under the assumption that words in different languages are similar when they talk about the same topic or concept, our intuition is that the right level of lexical alignment between languages is a concept, especially for typologically distant languages. For example, here we have the concept fruit, and we have the words that are related to the concept fruit in source language and in both source language and target language. Here we have the same situation for concept animal. But for doing this, we have to answer two questions firstly. The first question is how to get concept aligned data. Our solution is to use Wikipedia documents. Because Wikipedia offers us more than 40 million articles in more than 200 languages, and many articles are linked together by concept. The second question is that how to map words in different languages that describe the same topic. We consider this question as a distribution level mapping, and we use generative adversarial network. So for standard generative adversarial network, we have our source data, we have our distribution of target data. We need to use a generator to generate targeted samples, and we have a discriminator which discriminates whether the input is come from the target distribution or not. When we use GAN for cross-lingual word embedding, the generator becomes to learn the transformation matrix that maps the embedding from source language to target language. The discriminator becomes to detect whether the input is come from the target language or not. Here you can find the general objective function for GANs for cross-lingual word embedding. But a good transformation matrix can make the distribution of generated embedding similar to the distribution of target language. But NumPy showed that without any post-position, the distribution level mapping are usually not accurate when we look at the specific word. Here we can find a space for English and a space for Italian. When the preliminary mapping matrix is learned, these two spaces are not mapped together perfectly. You can find the architecture of our model in this figure. So we have a generator, which train the mapping matrix. We have a discriminator on concept, which judge whether the input follows the subdistribution conditioned on the sampled concept or not. And we also have a user language discriminator, which determines whether its input follows the real target language distribution or not. As the discriminator is a novelty of our model, I will talk more about it. When we have a set of source documents and a set of target documents, and both these documents are aligned together by concepts. We first sample a concept, and then we sample two words in source language and target language, which are used to describe the same concept. We use generator to generate GVS, and it will concatenate GVS, concatenate the vector of concept with GVS and the vector of concept with VT. And the discriminator on concept determine whether the input vector is come from the subdistribution condition on concept or not. Our method also includes some shared components, which previous works have proven useful for the performance. You can find them in our paper. Here, I just want to talk about more the post-refinement. Lampo showed that the cross-lingual mapping can be improved by bootstrapping from a dictionary learned by itself. So what we do with the mapping matrix, we use 10,000 most frequent source words, and we obtain a dictionary. And I use this dictionary as a seed dictionary and to update the mapping matrix. For evaluating our method, we have two tasks. The first task is a general evaluation task called a bilingual lexical induction, which evaluates the quality of predict translation. And we have another task which called cross-lingual semantic or similarity, which evaluates how well the predict similarity correlate with human judgments. We have three baseline, unsupervised baseline called MUSE, and two supervised baseline WACMap and POCUST. For the data, for the bilingual lexicon induction, we have two data sets, BLE1 and BLE2. We have, for the cross-lingual semantic or similarity, we use the data set of 7 April 2017. We determine similar language pairs and distant language pairs according to the directional dependency distance. So we have, for similar language pairs, we have English to German to French to Spanish and to Italian. For distant language pairs, we have English to Finnish, Russian, Turkish, and Chinese. Here you can find the results on the first data set of bilingual lexical induction for the similar language pairs. We can see that we have the best performance on 5 directions. And we perform better than MUSE, which is fully unsupervised method. And we have no significant difference between our method and our supervised baselines. Here you have the result for BLE1 for distant language pairs. We can find that we have the best performance on 3 directions, and we perform much better than MUSE. And we have a comparable performance with our supervised baseline. Here is a graph of average error reduction. Compare our method and our baseline method, our supervised baseline. For result on the second data set of bilingual lexical induction, unfortunately, we don't have the best performance. But except the model of Arctish, our model performs the best and work better than previous supervised and unsupervised system. For the results on cross-lingual semantic or similarity, we can see that we have comparable performance with supervised baseline and unsupervised baseline. And we have the best performance for English to Italian dataset. We also did a research on the impact of the number of concepts used for training. And we find that when the number reach at 2,500, the improvement of the accuracy is already very close when we use the total number of concepts. Here you can find some mapping examples. We can see that both our model and the Muse are able to predict good translations. But there is an interesting phenomenon is that for the English word battery, the Chinese translation predicted by Muse all related to the word battle or to the word cannon. But the translation predicted by our model are related to the battery that we use every day. So for conclusion, we propose a weakly supervised adversarial training method for cross-lingual word embedding. And the result of our experiments show that supports our intuition that mapping across language is better done at the concept level than at the word level is correct. Without post-refinement, our performance, our method performs much better than current unsupervised method. And after post-refine, our method becomes comparable or even better than current supervised method. Thank you.
Any questions? We still have time.
Hi.
Hi.
Have you considered trying applying your post-refinement on the supervised models as well?
Sorry?
Have you considered a way of applying your post-refinement step on top of the supervised models that you compare with as baselines as well?
No, I didn't consider it, but...
Would it be possible? So basically the kind of limited gains that you report compared to supervised baselines, do they come from the adversarial concept-based alignment or do they come from the post-refinement?
You mean the seed dictionary that we use for post-refinement?
Yeah.
No, it's from the preliminary mapping matrix that we trained with weakly supervised method. It's not from...
Yeah, but you could do that on a clean dictionary, some small size clean dictionary as well, right?
I think
you could apply the post-refinement
okay, I think
it's
possible, and yeah, I will try it. Thank you.
I believe that would make for a fairer comparison. Yeah. Okay, thanks.
Thanks.
Okay, any other questions?
I was wondering how many runs you did and what's the variance between runs?
Sorry, what's the variance between?
Runs? Like how many runs did you do?
For the post-refinement?
Or for in general, all of your experiments?
We didn't do multiple runs because since our model is kind of condition gain, so it's more stable than unsupervised gain. So we find the same, in most cases, we find the same performance for the training.
So your supervision is coming from Wikipedia, if I'm not mistaken.
Yeah.
And the motivation is that this is more available than bilingual dictionaries. But Wikipedia is only available in about 300 languages. I wonder if there's any supervision beyond Wikipedia, or have you thought about that?
Our intuition is not that Wikipedia have more language pairs than dictionary, or Wikipedia is more easily to obtain than dictionary. Our intuition is just we think that concept level mapping is better than dictionary word-to-word level mapping.
But you need to have these languages share as the same concept, set of concept.
Yeah.
So you how to do that? If we don't have Wikipedia, so you still have, you do still need some other
Yeah, the
resources.
precondition for our work is that we need to have Wikipedia, and Wikipedia is free, and so it's
Okay, you should have some shared concept hierarchy
yeah.
settings. Okay. Any other questions? We still have 2 minutes.
I think at least on the slides, you had what I would call high resource languages, German and Chinese and such. How much parallel corpora were used for your supervised baselines?
Okay, for the supervised baseline, I think we have used 5,000 words for dictionary. Yeah, if I didn't make a mistake.
So if I ran Giza on parallel corpora for Chinese English, how would I compare on bilingual lexicon induction?
Sorry, I can't get to.
If I just ran word alignment on parallel corpora that's plentiful for German, how would I compare?
So sorry, I can't get you what you want to.
Can you explain again?
Because
There's a lot of German-English translations out there,
Yeah.
right?
Yeah.
Parallel corpora.
yeah,
So, I'm sorry, I'm a machine translation person. If I trained word alignment on German-English parallel corpora, how well would I do on your task using the tens of millions of sentences out there?
I think this is a totally
yeah,
different
but-
task. I think. Yes.
yeah. Firstly, it's different task because the how to say it. You have 1 minute. If imagine you have 1 minute. If you use machine translation to train 1 minute dictionary, 1 minute word, dictionary of 1 minute words, I think your dictionary will be much noisy, and I don't think the performance when we're using 1 minute words of a dictionary of 1 minute words is much better than when using our dictionary of 5,000 or 10,000 words, because the dictionary that we use is in good performance, good quality.
Okay. I think time is up. So let's go to the next speaker. Okay. Thank you.
Thank you.